The number one cause of production container crashes: memory exhaustion. Let's fix that. In Docker, you set memory limits with the -- memory flag or its shorthand -m. Pass it to Docker run before your image name. For example, Docker run -meters 512 meters Linux Linux container to 512 megabytes of RAM. This is the most common way to control container memory in development and production. Memory limits accept several unit formats. You can use meters for megabytes, G for gigabytes, or spell them out as MB or GB. All of these are equivalent: 512M.5G and 512MB. Choose the format that makes your configuration most readable. Docker also lets you control swap memory with -- memory swap. If you set memory to 512 meters and memory swap to 1G, your container gets 512 megabytes of RAM plus 512 megabytes of swap. If you set memory swap to the same value as memory, swap is disabled. Setting memory swap to -1 allows unlimited swap. For declarative deployments, use Docker Compose or Kubernetes manifests. In Docker Compose, add a memory key under deploy resources limits. In Kubernetes, use resources.limits.memory in your pod spec. Both approaches let you version control your memory limits alongside your application code. When a container exceeds its memory limit, the kernel's out-of-memory killer terminates the process immediately. Your orchestrator will typically restart the container, but you'll lose any in-flight work. This is why setting appropriate limits is critical. Memory limits keep your containers in check and your production system stable. Practice setting them in your next deployment. Subscribe for more infrastructure interview prep. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.